Lesson 123, the biggest item in here is all sorts of different stuff about electrical, household, cooking appliances, residential ranges, things like that. And we're going to spend most of our time on one particular table, and that is table 220.55. Now there's a lot of kind of advanced ideas, and this is honestly one of the more difficult and technical lessons I think we have. I do tend to stress this pretty hard because when I went and sat for my Chambersburg Masters exam, they really hit a lot of the stuff from this table pretty hard. I felt pretty unprepared, so I'm hoping, if any of you guys go take that someday, you don't have that issue. So I do tend to stress this pretty hard. Other than that, as an everyday electrician, you're really not doing this stuff all the time. But anyway, so again, table 220.55, I'm going to break it into two sections. Basically, this top section, which is kind of all the info and the data, and then this bottom section, which is just 5 different notes. We're going to really focus on about 2 of those pretty hard, but we'll look at the top half here. Essentially what that tells us down along the left is how many appliances do we have. So everything we talk about here has to do with what size should our branch circuit be, and what size should if we have a feeder circuit that's feeding a sub panel or an entire building service, how many amps do we need to include in that service for various amounts of electric cooking equipment. So the first instance, your branch circuits, we're talking about maybe a single residential home. We have 1 or 2 or 3 electric cooking appliances. How big should that branch circuit or feeder circuit be? And then the second instance is we're sizing a service to a whole building, maybe an apartment building that's got 5, 10, 20 different ranges in it. So we'll go to various columns in the table. So the left-hand side says how many pieces of equipment do we have. Obviously you get to the lower end, that's your apartment buildings, things like that. And then we have these column A, B, and C depending on the size of the equipment. So if it's anything less than 3.5 kilowatts, we're in column A. 3.5 through 8 3/4, we're column B. And then essentially anything over 8 3/4, we're in column C. You see this not over 12 kilowatts, and we'll touch on that here in a moment. But for the notes section, we'll get into some of these. Again, we're really going to hit on note number 1 and note number 4. And you'll see this gets really complicated pretty quick, so we'll try and break it down. So some other things to clear up, we're talking about 3 major pieces of equipment here in particular. That's a freestanding range. So when I say that, that's probably what most people have in their homes. That's kind of, again, freestanding. It's not attached to anything. It's literally sitting in amongst your cabinets. Your wall-mounted oven, that's this guy that's built right into a wall or a cabinet of some kind. And then your counter-mounted cooking unit, or a cooktop as some people might call it. Notice this is cut right into the counter. There's no base unit to it. Okay. Most times if you have one of these, you don't have either of these. If you don't have this, you're going to have at least one of each of these here. Right? And then some various situations we want to touch on. So number 1 is a single range that is over 12 kilowatts. We'll talk about why that 12 kilowatts means anything. Number 2 is a single counter unit plus 1 or 2 wall-mounted ovens, which again, if you don't have a range, that's probably what you have. How do we size that circuit? And number 3, let's say we have to size a feeder or a service for, say, that apartment building again, right? So jumping into our first instance here, a single range over 12 kilowatts. So if I go back to note 1 on the table, it tells us over 12 kilowatts through 27 kilowatt ranges, all of the same rating. For ranges individually rated more than 12 kilowatts but not more than 27, the maximum demand in column C shall be increased 5% for each additional kilowatt of rating or major fraction thereof by which the rating of the individual ranges exceeds 12 kilowatts. So you'd have to be a lawyer and an engineer to understand what that truly means right off the bat. That's a very complicated sentence. So let's try to break that down a little bit. Okay, so our first issue was, remember column C said it focused on ranges not exceeding 12 kilowatts. Well, what happens if we do? Well, in this case we do. And this one in our example, let's say is 14.75 kilowatts, right? So our first problem is they want to know how far over 12 kilowatts did we go. So for each additional kilowatt exceeding 12 kilowatts. So how far over 12 did we go? Well, we can do that by subtracting 12. we come out to 2.75. Okay. So the next section worth noting says, or major fraction thereof. So what does that mean? Well, it essentially means you're going to round up or round down accordingly, right? So 2.75 would round to 3 kilowatts, because 0.75 is a major fraction thereof of 1 kilowatt, right? So essentially that just means round up or round down accordingly. Okay, the next piece we need to understand is we're going to increase by 5% for every kilowatt that we've gone over 12. So we went over by 3 kilowatts. We're going to increase by 5% for every kilowatt. So 3 times 5, 0.05 in this case, gives us 15%, or 0.15, right? Okay, so we're going to increase by 5% for each kilowatt. Increase what by that percentage? Well, you know, it's going to tell us here we're going to increase the original demand factor in column C. Okay, so again, let's just jump back and check that. So our column C again is over here, not exceeding 12. Well, we did. So our original demand factor for one appliance in column C is 8 kilowatts. Okay, and remember that, you're going to use that a lot. So we need to increase that original demand factor of 8 kilowatts by 15%. So why do we have 1.15? Well, we need to keep the original 100%, which is represented by 1, and we need to add 15%. So we can simplify that by saying 1.15 times 8, the original kilowatt rating of column C. So you do that math, you get 9.2 kilowatts. So we're just about done with this, believe it or not. So we're going to do a little Ohm's law here. So I'm going to convert this kilowatts down to watts, right? I'm going to find out how many amps is this actually going to take. In a residential instance, I know I'm at 240 volts. So again, 9,200 watts, which comes from our 9.2 kilowatts, divided by 240 volts gives me 38.333 amps. If you guys know anything about typically wiring up residences, most times the range is a 50 amp circuit anyway. So we're actually covered, and this exception sort of lets us slide in under that as well. So again, that was a lot. This is boiled down into just a few steps, and I'm going to have a link to a little worksheet that I've made. You guys can sort of plug numbers into and follow along, but please check that out and download it, print it, whatever you want to do. But it just walks us through what we just did there. Okay, so that's the first instance. We have a range over 12 kilowatts. Okay, this next one here, a single counter unit and 1 or 2 wall-mounted ovens. Okay, so again, note 4, if we remember, and in particular we're worried about this section, the branch circuit load for a counter-mounted cooking unit and not more than 2 wall-mounted ovens, all supplied from a single branch circuit and located in the same room, shall be calculated by adding the nameplate rating of the individual appliances and treating this total as equivalent to one range. So really what all that says is we're just going to add them all up, right? And again, they're pretty particular. It's 1 counter-mounted cooking unit and not more than 2 wall-mounted ovens. But if that's the case, just add them all together. If it does happen to go over 12 kilowatts, we're going to do the steps we just did in the previous example. After you add them up, you're going to treat them like any one range, right? So our last sort of example or situation is if we're trying to size a feeder or a service calculation, how many amps do I need to include in this whole building service to handle the electrical cooking appliance load of again, say we're various apartments, right? So again, an apartment building, in this case, let's just throw out there we have 6 ranges that are rated at 5 kilowatts. Maybe we have some efficiency apartments in there, and then we have 10 ranges that are rated at 9 kilowatts. Okay, so really the first thing you're going to do is just gather what size ranges and how many of them, right? So for this first category, we have 6 ranges at 5 kilowatts. So you'll notice right away 5 kilowatts put this in column B, 3.5 up to 8 3/4, right? And since we have 6 of them, when we come across this way, we see that we intersect there at 43. Now notice demand factor percentage. That's a 43% is what that's representing, right? So 43%. So let's first find out how many kilowatts is that at 100%. So 6 ranges times 5 kilowatts gives us 30 kilowatts, and we just found we need to take that by 43%. Gives us 12.9 kilowatts need to be included for those first 6 ranges. Okay, so we're going to jump over to the next category again. That was 10 ranges at 9 kilowatts. So in this case, since we're over 8 3/4, we're in column C. it's something to note if you didn't already catch it. Column C now is not a percentage. This is just a kilowatt value right away. There's no math needed. They're telling you what to use here. So again, in this case, we said we had 10 ranges at 9 kilowatts. So we're going to come down here. We say, like I just said, column C, 10 ranges. That tells us we need to carry 25 kilowatts for those 10 ranges, right? So we now have 12.9 kilowatts for this set. We have 25 kilowatts for this set. We can add them together for our total kilowatt value of 37.9. Again, I want to turn that into amperage. So we're going to use some Ohm's law here. I'm going to translate that from kilowatts to watts. We're going to divide it by 240, as is the case in most residential installs. Comes out to 157.917 amps. So and if we're sizing that service, we need to carry 157.917 amps for just the ranges in this case. So listen, that was about 11 minutes. That really should be probably a 1 or 2 or 3 hour lesson. So please take your time going through the book. Maybe you rewatch this again. I'll put a worksheet up for that section on ranges that are over 12 kilowatts. Spend some time with it. Don't get too hung up. Again, as a working electrician, this isn't terribly important. I did see a lot of it on various exams, so I do kind of stress it. So you do want to have a basic idea and familiarity with our tables and everything. But like I said, don't get too hung up, and please read the examples, watch the video, go through it all, and feel free to check out that worksheet as well.